what we have here is we've been asked to find the 40th term of the arithmetic sequence below. So this is our arithmetic sequence. It gives us a few of the terms. So what we need to consider is firstly, and ignore the text down here for a second, I'll just write out kind of what I would write down if I was doing this question, kind of as a beginner. What I typically like to write down is what I want to find. So I want to find T40, right? I want to find the 40th term. The other thing I know from needing to find T40 is that we have this equation here that we need to use to find our term. If you're a little bit confused about which formula to use, so we've been given two formulas. We have the general definition and the recursive definition. So remember, the general definition, which is the one that we have in blue here, is to find any term in a sequence. The recursive definition is to find the following term in a sequence. So if we were given term 39 and then asked to find term 40, we could use the recursive definition. But because we aren't given term 39, we just want to like pinpoint somewhere down here in this long line of numbers where term 40 is, we need to use the general definition, which, as I said before, is typically the one that we use more in year 11. So from this formula, we know that we need to find term 1, n, and d. We know that n is going to be 40 because we need to find term 40. Our first term is going to be the first term in our sequence, so it's going to be 6. And then d, we need to find d. So remember, d is the common difference between each of the terms. So this might seem obvious to some, but just as a general formula to find d, it is going to be the term n plus 1 minus term n, because this is going to give you the difference between them. So what it basically means is just any preceding term minus the term before that. So we can use 18 minus 6, which gives us 6. But you can use any two terms in the sequence. We could use 54 minus 42. And that is going to give us, it's going to give us 12. No, what I was thinking then. Listen, I study maths in university and sometimes my brain just does not work. That's going to give us 12 as well. Really quickly, for kind of mistakes like that I just made, where you kind of like add two numbers wrong or something like that. It's very simple, but your brain just kind of like doesn't compute it correctly. What I found really helps to avoid that, and if you have any more questions about what I say as well, please ask in the live chat. But what I found really helps to avoid that, this is what I did throughout year 12, and I managed to like not make a lot of mistakes like that at all, is to just think really, really, really consciously about everything that you're doing, like really overthink everything. If you're an overthinker, it's your specialty, overthink everything, even for really, really simple additions and subtractions, or for determining which formula you're going to use, something like that. You need to just think through like every single step that you take. So you think, what do I have? 18 minus 6. So I have 8 minus 6. That's going to give me 2, because 2 plus 6 is 8. Yep, that's definitely right. And then 18 minus 6, well, it has to be above 10 because, and and you just think through it really consciously. Because the reason I made that mistake right there was because I wasn't thinking about it too consciously. I was focusing more on explaining it to you guys instead of actually thinking about the maths in my head, even though I have it written right here. But my point is, especially in your exam, just make sure that you are thinking through everything that you're doing. It's really easy to try and do all the questions really, really fast because you're worried about running out of time. What I'd recommend is just make sure you practice the questions, be really well versed in the content before your exam so you're not spending time trying to remember content, and you can instead use that time to think through every single step that you're doing. Because I completely understand how frustrating it is to understand all of the content and then make really silly mistakes and then lose marks, and it's just like so annoying because you spent so much time learning the content and then you're just going to lose marks for doing things that like you know that you should be able to do. But yeah, if you have any more questions about that, please feel free to ask. But yeah, even just like checking that you're using the right formula, even if you think you know a formula, go back to your formula sheet and check that you're writing it out right. Or, think, why am I adding these two numbers? Am I sure that I shouldn't be taking them? Anything like that. Anyway, moving on to the rest of the question. So, as you can see here, we now know all of our values and we can substitute them in. So T40 is going to be our first term plus our difference multiplied by n take 1, which is going to give us 474. A good thing to always check with these questions as well is that your number kind of makes sense within the context of the sequence. So we know that our sequence is increasing here, so it makes sense that our 40th term is going to be like way higher than 6. However, if, for example, the answer that we got was negative, say we got like negative 1,000, we'd be like, well, our sequence is obviously increasing, so why did we get a number lower than 6? Why did we get a number lower than the first term? Just to make sure that you haven't made like a simple mistake like that, and that your answer kind of makes sense and is like reasonable. So yeah, just have a look at whether your sequence is increasing or decreasing, and like also how far in the future your term is. This is term 40, so it makes sense that it's like way bigger than our first term. But if this was like only term 10, it'd be like, well, how did we get to 474? Okay, moving on to a harder application of arithmetic sequences. So, arithmetic sequences can also be used in the context of linear growth or decay. And of course, it's linear because we are always adding the same amount every time. Our difference is always the same. So, as a method of understanding, and again, jot this down for when you're learning geometric sequences, because this is very different when you're learning geometric sequences, and it's useful to understand why it's linear. Remember, like a linear curve might look like this, and if our gradient is, say, like 1, it means that our curve is always increasing by 1 for every 1 we go across, right? So it's always increasing by the same amount. But if you have a different curve that is, say, like this, then this curve is going to be not increasing by a lot when it is down here, but as it gets up here, it's going to be increasing by a lot more at a greater rate. So this is why our arithmetic sequences are linear, because we have a constant difference, which means that the gradient is always going to be constant. Okay, but yeah, jot that down for when you get to geometric sequences, because that is important. So, as an example of a question you might come across, is for simple interest. So if Amanda is paid an initial salary of $60,000 per year, Each year her salary increases by 1,500. What is her salary after 30 years and how much has she earned over that period? So, what we need to do here is we need to apply our arithmetic sequence general expression, and we need to kind of convert all these numbers that we were given to values in our equation. So, if Amanda is paid an initial salary of $60,000 per year, this is going to be our first term, right? Because she's paid $60K. With each year, she's going to be paid an additional 1.5, but her initial value is going to be 60,000. That's the starting value. Then of course her difference is going to be 1,500. And then because the difference occurs once every year, her salary increases by $1,500 every year. The N is also going to be in years, so her salary after 30 years. One thing to look out for is if your difference and your N have different units. If it had asked for her salary after like a certain amount of months or something like that, then we would have needed to convert. So keep a lookout for that. Questions typically try to like do little things like that just to kind of trick you up and make sure that you're paying attention to get the full marks. So applying our formula, we're going to get that term 30 is equal to $103,500. So it's a whopping salary. Okay. Getting on to our next topic, which is the sums